Hi everyone, welcome to my channel. Today is the day 27 of May series and the problem is possible bipartition. So it is given that we have n people and we would like to split these people in based on they like or dislike the other people. So it is given that dislike array, so where dislike of I is consisting two nodes, basically two vertex or two persons number, one A and B. It means like A don't like B and B like A don't like A. So basically A dislike B and B dislike A. So we have to basic convert every, we have to segregate, basically partition these persons based on their dislikes into two such groups where there is no cross disliking. In that, if it is possible, we can easily partition these two in two groups, then we have to return true, otherwise we have to return false. So in example 1 we have total four persons and the person 1 dislike 2 and person 2 is also dislike 1. Similarly person 1 also dislike person 3 and person 3 dislike person 1. Person 2 dislike person 4 and person 4. So we can group them, person 1 and person 4 here in one group 1, and person 2 and person 3 can group them in a group 2. So we can participate this four person and with their dislikes preferences, so we have to return true. In case of second example, like we have three persons and person 1 is dislike person 2, also person 1 also dislike person 3, and in that case we need to move person 1 in one group and person 2 and 3 in another group, while there is another dislike pair where person 2 also dislike person 3 and vice versa. So we cannot keep both of them in a same group, also with the person 1 both of them dislike, so we cannot. So here it is not possible to partition in these persons in two different groups, so we have to return false. So let me draw a little bit a picture. This solution might go a bit longer as compared to the my previous solutions. So here, like, we have person 1 in the example 1 here, person 1 dislike person 2, also person 1 dislike person 3, and person 4 again dislike person 4. In the example 1 it is given that, so we can easily club this person 1 and person 4 in one group and person 2 and person 4 in another group. So this is, if I again transform this, like person 1 will be here, and sorry, so this will be person 1 and 4. So person 1 and 4 in a one group, which is group 1. Similarly, so this person 1 dislike person 2 from the group 2, so this is group 2, where person 2 and 3, here it is a G2 group 2. So person 1 dislike person 2 and person 3, similarly person 2 dislike person 4. So individual dislikes are, we are able to categorize in two groups. So this is for example 4, and now let's me draw the example number 2. So in example 2 we have person 1 which dislike person 2 and person 1 also dislike person 3, while and also person 2 dislike person 3. So here this is, so if I try to club them, like this will go in one group, with this way this should go in one group, but with this, but because of this age also edge their dislikes of person 2 and 3, we cannot, so we can't do participate partition these persons. So if we clearly see, like this is a undirected graph problem where we have to segregate the vertices into groups, so that each vertex of one group is colored with one color, let's say, and another group vertex will be colored with another. So it is a basically a graph partition problem and coloring problem. So if I, so for this we will solve based on the both approach like BFS and DFS traversal, and we will keep track of coloring. So for BFS, if we start like let's say this graph, so we have graph 1. I am redrawing again the graph 1 here. So 1 has as with 2 and 3, and 2 has as with 4 as well. So let's say our starting vertex is 1. If we are starting, we can go, let's breadth wise. So if we color this with the, let's say, red, the first vertex, so red color, and adjacent vertex we have to color with another color, let's say blue color. So this vertex we will color with blue color, which are the adjacent closest neighbor of the vertex 1, which is colored with red. So we can, then once we go in another level, then we have to again color with the red. So if we are able to do each vertex, alternate vertex with red and blue color in successfully, in that case we are able to bipartition this persons into two groups. Otherwise, if we are not, then we cannot. So this is a, I so, like this is a breadth first approach. Here goes here and this goes here, and then after that go to here and color this vertex. So let's start implementation first from the given graph. So and let's see the constraints. Constraint is like total number of vertices or the person possible max is 2000, and the length of dislikes is 10,000, and the dislikes of I of j is contain only the value of the among the vertices, and dislikes of I0 is always less than I of 1. So it is a kind of, we can think that the dislike is like an edge between the two vertices, where the vertex 1 is always less than a, and there is no such edge which is like self edge in the graph. So first we are given a dislike array of 2D array and number of vertices. First of all, what I will do, I will get the convert this dislikes edges with the help of node into the graph using the adjacency list representation. So it will be adjacent this integer list of integer of array, which is a graph. We will create a util function which will construct a graph with the given vertices and the dislikes. So let me write down first private method to construct the adjacency list representation of graph. So construct graph with the given number of vertices int n and the int array, let me name it as edges. And now we need to create a list of integer array, which is a graph is equals to new array list of array of n vertices. So after that we will initialize the graph of for all int I is equal to 0, I less than n, I plus plus. So graph of I, so I'm like basically reducing 1 to basically the graph map the person 1 with the 0 graph index of the array, so that it will be easiest to do in the calculation. So I will map this with that. So first of all we have to create array list here, new array list for every I, and after that we will fill the edges like int array of edge in edges. So it is a undirected graph, so we need to add both. So let's say int u is equals to edge of 0, we will subtract 1 because we are taking down by 1 to map the array indexes. Int v is equal to edge of 1 minus 1. Now graph of u dot add b, and vice versa, graph of b at the adjacent in the adjacent node to of the list in the adjacency list of u to b and v to u. So this will construct our graph, and in the end we have to just simply return the graph. So this is a util method to create a build a graph. So let me comment out build the graph from n vertices and edges. After that we need to call the BFS implementation. So for BFS I will simply write another helper method which will we have to pass that method number of vertices and the graph which we got from our construct video. After that we will write a private boolean BFS intent list of integer array of graph, and here like we are not sure this graph maybe has unconnected components, so we have to basically run our start like treat our source vertex from the every node, and we will use a color colors array which will track the colors. So here new int of size will be n because we have number of vertices n, and then we will check for each vertex I equal to 0 and I less than n I plus plus. So if so for color mapping what I will do here, so the default value is 0 which means not colored at, and color 1 means group 1 belongs to group 1, and color -1, so I am using -1 color to represent into the group 2 because it is easy, we can alternate the colors from 1 to -1, just negate the sign group 2. Okay, so now if the colors of current vertex is not equal to 0 which means it is already colored, so we don't have to do again, just simply we will do continue for the other rest of the vertex. Otherwise we will color the current vertex with 1 starting, and then we will use the queue for BFS traversal integer q is equal to new linked list, and then add the current vertex q dot add current vertex is I, then we will run through the breadth first search while q is not empty. If q is not empty then we will get the int current vertex is equal to q dot poll, we will poll the q, and after that we will poll the q from the q, and after that we will get all the adjacent vertices from the adjacency list graph representation for the current vertex. So for int vertex in, or the better name is adjacent vertex for the from the adjacency list of graph of current vertex, then we will iterate through and check the color and mark the color if colors of adjacent vertex is already marked, basically it is equals to the colors of current vertex, which means two adjacent vertex has same color, we cannot segregate them into the two groups current vertex, then we will just simply return the false from here itself, because we already found a way where we cannot divide these persons into two groups. Otherwise if colors of adjacent vertex is equals to 0, we will first color this. So for colors of adjacent vertex is equals to negative of colors of current vertex. Okay, we will do the negative of color vertex, and after that we will add this current vertex in q dot add the adjacent vertex, basically adjacent because vertex in the queue, and that this will continue till the end. Once it done, once we process for all the nodes or vertices in our graph, if it is successful, from here we will return true, otherwise it will be automatically written from here because we cannot. So this is the BFS solution here. Let's try to compile it, if we are able to compile, or it is. So the code is going on and there is a construct graph, so cannot find the symbol, I guess some. Oh, this is a construct graph, I guess, and it should be same. Yeah, now another we are getting adjacent vertex issue. So color vertex adjacent cannot find symbol, so this symbol is not able to find in adjacent vertex. Okay, this one adjacent vertex, and anything else? No. If color adjacent vertex, okay, adjacent vertex, so we have this adjacent vertex, this one as well. So this is adjacent vertex everywhere. Let's try to compile it again. So the code is compiled and we are getting expected answer true. Let's check the other two remaining examples as a custom test. Here the custom test is this with the 3%, and this is array. Another one is with the 5, n is equal to 5 nodes, so the 5, and this is the array of edges. Let's try to run this. So this is what we are getting, and let's, the diff is, there is no diff, so what is expected we are getting. Let's try to submit our solution here. So this is got accepted. So this is the BFS solution, and if we see the order time complexities of this solution is, so time complexity, so we are going through basically processing all the edges to construct basically the graph. So it is, and then for each vertex now we are running the BFS. So construction of graph is in O of E. Let's say E is a number of edges, basically this is a length of the side, and n is a number of nodes. Also for the space complexity we are using colors array, which is O of n, and also for constructing the graph we are using adjacency list representation, where we will note down the all the edges. So this is also same as O of n plus E. So this is a breadth first solution. Let's move to implement the depth first solution. So let me little bit explain more in the DFS first in the OneNote. So for DFS again the same graph one, so person 1 here and person 2 with the dislike with person 2, as well as person 1 dislike with person 3, and person 2 is also dislike with person 4. So for the undirected graph, so if we go move from here to here, depth first, so we will mark this first color, first vertex as a, let's say, red. So the in depth we need to mark all the so this next vertex is with different color, which is a, let's say, blue. Then alternately we will mark the next vertex here, we will go in this depth first, so red. Then once this done we will come to this vertex, and this vertex comes from the tree of this, the child of adjacent child of vertex 1, so this will also marks as blue. So we can able to do here partitioning here, so this is also possible. So let's start the DFS implementation. So for DFS implementation we just need to call another method with the same structures, same definition, method definition. So it's a DFS of n comma graph. Again we will use the same graph we constructed for BFS, and here I will start method for private, return type is again boolean, and its DFS of get int number of vertices and the list of integer of array of graph. And here, so what we need to do, we again need to create a colors array is equal to new of int of n, and after that we will run through all the vertex same as we did for, because it is for the if there is unconnected component I less than n I plus plus. So if the colors of the current vertex is equals to 0, and if we do DFS, and if we do the DFS for that vertex, so we will use another util method that will recursively go through in the down of the vertices, so DFS util, and we will pass the graph for this method, and we need to pass the current colors array, and we have to pass the current color, so current color, and also the current vertex which is I, and the starting color, let's say start from the color 1. If this is returns true, then in that case we are not able to find, we have to return false, like we are not able to divide them. If everything is processed successfully, in the end we will able to divide them into two different groups, so we will return simply here true. So let me write down the util method, private boolean DFS util, which will get the graph list of integer graph comma int array of colors into current vertex, again current vertex comma int color, so current color what is running in the depth. So here we will check if the colors of current vertex, current vertex is not 0, basically already colored. If it is already colored, we just simply have to return if the color of current vertex is equals to the color of the given DFS path, basically assigned color, whatever the assigned color we are trying to assign. Otherwise, if it is not already colored, then we need to update the colors for the current vertex with the current color, and also we have to find all the current adjacent vertex for this adjacent vertex for the current vertex from the graph of current vertex, and then we will check if not DFS, we will recursively call this for all the adjacent vertex with passing graph again and the colors array, and the current vertex is now adjacent vertex, and this is after that the color is opposite of the current color, so colors of -1. If this return true, then we have to return here false. In the end, if we found nobody, like we are able to do for aggregate for all, we will just simply return the true. So this is the recursive DFS implementations. Let's try to compile our test for recursive implementation for all the input tests. Current given, there is a compile error, I guess, minus of color. Oh, I returned the colors instead of color, it's a color, not the colors array. So here in the recursive call, and after that let's try to run again code. So it's compiling and it's judging now. So what is expected we are getting. Let's try to submit our DFS solution, and it is going judging, it is also getting accepted. So this is a DFS recursive implementation. So let me put here again name of the method, DFS recursive implementation, and the time complexity again the same, because we are creating the graph of n plus e, where e is a length of the dislikes array, and also the space complexity is O of n plus e. So this is the solutions. We can also implement the DFS in iterative way using the stack. If you like, you can enhance this. So this is the basic idea. So if you are not much familiar with the graph algorithm, I would suggest go through, read little bit about the graph representations and the basic algorithm of traversal like BFS and DFS. This is quite easier, but in the first hand you have to know, and this problem you can easily implement if you are already aware of the problem. So that's it for this problem. Let's stop this here, and if you like my solution, please hit the like button and subscribe my channel for the future upcoming videos.